Hello friends, welcome to my channel. My name is Fikret. This video is part of video tutorial dedicated to learning Microsoft Fabric. Okay, now that we have discussed basics of dimensional modeling, let's see how they can be, these transformations can be implemented in PySpark. So back to my notebook, my next cell generates surrogate keys for customers table. And to do that, I am using with column method, and I'm also using monotonically increasing AD function, which is another function, native function from PySpark SQL functions library. Okay, so let's take a look at the data. So this is my customer key, surrogate key. If I scroll down, you would find something interesting. So here at some point my numbers jump from 210 to something very large, and if I continue scanning the table, I will find a few more key range. You might be asking why this is happening, and the answer is because Spark is a distributed computing system. So let's have a quick discussion around that. Let's talk about Spark clusters and the parallelism. So I mentioned earlier that Spark is a distributed computing system. So this is one diagram that I borrowed from Databricks sites. So it illustrates how this computing works. So in each cluster, you would find a driver node, which is kind of brain of your cluster. It distributes the task between working nodes. So these are the worker nodes. You may have one or more worker nodes depending on the size of the cluster. And basically the computing is distributed between these tasks so that your calculations computing in the fastest possible time. So in terms of data implications, data is also distributed between nodes. So for example, if you have this data set, this in a two-node cluster, your data will be distributed in half. So one part will go to one node, and then the rest will be taken care of to another node. Why is this important? Because when surrogate keys are calculated within each node, Spark needs to ensure that this range within the nodes are not overlapping. And because of that, Spark will assign one big range to each node so that you don't have overlapping problems. Each data portion assigned to individual node is called partitions. So to summarize, Spark cluster will normally divide your data into different partitions. This number of partitions will depend on multiple factors. One factor is, of course, number of nodes in your cluster, but also number of cores affect on how many partitions you have. All right, I am back in my notebook. Now let's find out how many partitions we have in this particular data frame. So if I scroll down, this is what my next command does. So it basically uses RDD APIs and then use get number partitions to find out how many partitions we have in this particular data frame. So in this case, we have 4, which means that within this output, you will find 4 different data range when it comes to surrogate keys. Fortunately, there is a way to adjust number of partitions depending of your problem. You may decide to increase partition count. So there is a command for that. Repartition method allows you to increase a number of partitions from default partition number. That could be useful in a scenarios when you are dealing with very large data set and you want to parallelize your computing and get best performance from it. However, in case of surrogate case, it's reasonable to expect that you would have continuous numbering without gaps. And to achieve that, all you need to do is to reduce number of partitions to one. To reduce number of partitions, you can use coalesce function described here. And if I run my next command, I have one. And if I run my transformation again, now we should be able to see continuous range of numbers. Okay, now that we learned how to generate surrogate keys, next question becomes how do we link fact tables to dimension tables? So as explained earlier, when linking type 2 tables, you want to link them on surrogate keys. And to achieve that, we can use join transformation, which is part of my next command. So here I'm using join. As argument, I am provided a second data frame. So basically I start with first data frame here. And then I apply join method or join transformation. And this join transformation requires two arguments. The first argument is going to be the data frames that you are joining to. And the second argument is going to be keys on which you want to join. In a simple case where your keys are same from both sides, you can have this simple syntax where you just list one key here. In more complex cases where key names are different from each side, you can use some syntax like this. Here I'm joining date dimension, and this is my second data frame, and this is my join condition. So I say from orders data frame side use this field, and then from date data frame side use this field. Another thing to notice here is that I am using join based on business key to bring surrogate key here. So you can see I'm using customer ID here. So for date table, it doesn't matter, we don't have surrogate keys there. And from this table, I want to have customer key, which then I am using in select statement just to narrow down to necessary columns. So as a result of this transformation, this is my data set where I've got data key, date key, and the customer key inside my fact table. And my fact table no longer contains a customer ID, which was business key.